All right, guys, second video. Here we go. All we're doing now is combining all transformations together. We're going to do a sine graph, a cosine graph, and a tangent. Okay, let's start with the sine here. Amplitude. A value out front is 2, so my amplitude is 2. Period is affected by the B value. So the period is 2 pi divided by 2, which gives me just pi. Phase shift is the C value. I'm going left. Pi over 4, and the D value plus 3 takes me up 3 units. All right, so my sine curve, I kind of always keep a little sketch up here to remind me. Looks like this, right? And I'm taking this key point here, the one that starts at the origin, and I'm moving it left pi over 4. So I'm going to have these tick marks here on this graph represent pi over 4, so negative pi over 4. And the midline is going up 3. So 1, 2, 3 up is going to mean that is the middle, the horizontal middle of my graph. All right. Now, I have to find the 5 key x values. Again, sometimes that's the trickiest. Here, I'm going by pi over 4s. So I'm going to travel out here pi units. If each tick marks here pi over 4, I need to travel 4. So 1, 2, 3, 4 means that's where this period is going to end. Be careful, don't put a pi there. You start at negative pi over 4 and you have to add pi to that, which gives me 3 pi over 4. All right, so there's the beginning, there's the end. Now, to find the halfway in the middle, you have options. You can realize that because the period's pi, each interval here is going to go up by pi over 4, and you can just add pi over 4 plus pi over 4 plus pi over 4. Or to find this middle guy here, you can add the endpoints, negative pi over 4 plus 3 pi over 4, which gives me 2 pi over 4, and then times that by a half, which is going to give me 2 pi over 8, which is pi over 4. So that should be halfway between negative pi over 4 and 3 pi over 4, which it is. All right? Now, halfway between pi over 4 and negative pi over 4, I'm not going to waste any time doing that. That's just 0. And halfway between pi over 4 and 3 pi over 4, again, either add another pi over 4 going this way, or add these two endpoints up and multiply it by a half. Whichever way you do it, you're going to get pi over 2. So there's the x-axis. Now, to finish the graph, we took the midline up 3 units. The amplitude is 2, so I'm going to start here in the midline. I'm going to go up 2 to the tip top here, down 2 to the midline, following that sine pattern, down 2 to the bottom, and then back up 2 to the midline. And there's my sine curve. Sketch it in. No V's. Make sure this is nice and smooth. The 1 period of the sine function. Now again, it keeps going after this, makes more of these loops, or curves I should say. It keeps going after this and makes more of those curves, but we're just graphing 1 period. So that's all we need to see. I would also throw an a value on the y-axis, put a 6 up there just so I know what you're going by. Okay, there's the first curve. All 4 different kinds of movements and transformations going on. Let's do a cosine curve. Okay, so this graph, I'm not giving you an x-axis, so you can, because of the spacing, you got to just make sure it's spaced correctly and show me the 5 key x values. Now, one thing I will do, I'm going to go right pi over 3 here. That's my phase shift. And because I don't know what I'm going by, I'm going to put a little break in the axis right there. I know we've talked about that before. All that means is that this first space right here, doesn't necessarily need to be equally spaced out like the other spaces, right? I know I'm moving right pi over 3, and that's going to be the beginning of this period I show. Amplitude is the A value out front, so it's 4/3. The period here is 2 pi, because it's cosine, divided by 1/2, which is the B value. When I multiply by the reciprocal, I get a period of 4 pi. So there's my period, 4 pi. I already did the phase shift right 3. And the vertical shift is up 2 units. All right, so my midline here is going to be up at 2. Let's see where we can put that. Let's go 1 there, 2 there, 3 there. Try to make them equally spaced. I know I'm going to use all 3 because I have an amplitude All right, so there's the middle. Now let's find the x-axis here. Make that a little straighter. All right, so I'm trying pi over 3. I need to travel out here to the end of the period. That has to be 4 pi units. So pi over 3 plus 4 pi. Come down here, do a little fraction work. Pi over 3 plus 4 pi. Give common denominators here. That's 12 pi over 3. Add those up, you get 13 pi over 3, which is going to be out here, 13 pi divided by 3. All right, now to find halfway in between those two guys. Now again, you could also do this. To find your 5 key x values, you can realize that a fourth of the period is pi, so that each one of these are going to increase by pi units going left to right. Sometimes I do that. Sometimes I add up the endpoints and find the middle. Add them up and times by half. So that's what I'm going to do here. So right there is the middle. Pi over 3 plus 13 pi over 3 gives me 14 pi over 3. And when I multiply that by a half, I get 7 pi over 3. That's right in the middle there. Now halfway between 7 pi over 3 and pi over 3, same technique. Add those up and multiply by half. I can kind of add that in my head. Pi over 3 plus 7 pi over 3 is 8 pi over 3. Multiply that by 1/2, and I get 4 pi over 3. So halfway there is 4 pi over 3. Now, here you might see a pattern. It's completely up to you. We said a fourth of the period was pi, and look what's happening here. I'm adding pi, adding pi, adding pi to get to here, and adding a pi after that. But I also see a pattern in the fractions. Look what you're doing in the numerator, starting with 1 pi, then 4 pi, then 7 pi. You're adding 3 each time, which makes sense because 3 pi over 3 is a pi. So for this last one, this value here, I know if I add 3 to 7, I'm going to get 10 pi over 3, which is my last key x value. Okay? So again, there's many ways to find those key x values. Find whichever way you like. Maybe have a few so you can use whichever one's easiest for the given problem. Okay, now cosine curve. Remember that one looks like this. Starts up at the top, above the midline, and loops down, comes up. So I've got to keep track of my amplitude. My amplitude here is a little bit over 1. Okay, so I have to start right pi over 3 and up. Now I'm going to label this x-axis at, this is 3 and this is 1. My midline's at 2. I'm going to go 1 1/3 above 2. So I'm going to be up approximately right about there, above 3. At 4 pi over 3, I'm down at the midline. Now at 7 pi over 3, I need to be 1/3 below 1. So maybe right about there. And at 10 pi over 3, I'm back to the midline. And at 13 pi over 3, I'm back to the highest point, which is 3 1/3 up there. And there's my graph. Sketching your cosine curve best you can. Again, this is the one period of this cosine curve. So we can get an idea of the shape and what it looks like. All right, so there it is. We moved it right pi over 3, we moved it up 2, we stretched the period to 4 pi, we increased the amplitude to 1 1/3. All right, let's try a tangent graph. Okay, for tangent, all the same stuff. Okay, again, I'm giving you this blank graph here because the period and the amplitude and the phase shift don't really match up that well. Tangent graphs don't have an amplitude, so if I ask you, put none. Now this 3/4 is going to help us out. It's going to help us figure out how high and low to go from the middle, how to get to this point and to this point, right? Now we're going to have asymptotes here and asymptotes there. Okay, so no amplitude. Period is pi divided by the b value. Here the b value is 2. Nothing simplifies. So my period is just pi divided by 2. Pi divided by 2. All right, phase shift I have here is left pi over 3. So left pi over 3, and then down left pi over 3, and then down 1. Okay, let's start making my x-axis here. Now remember, when I move this guy left and right, I'm moving this center of the graph, right, which was at the old origin. I'm moving that left and right. Right, this used to be at the origin, so I'm moving it left to pi over 3. And from there, I'm going to travel half the period each way. So I want to start thinking about the spacing. Pi over 2 times a half is pi over 4. So that means from my left movement of pi over 3, I want to travel pi over 4 units to the right of that. Okay? That means I'm going to stay negative, right? Pi over 3 is bigger than pi over 4. So I'm going to give myself enough room over here to keep everything on the negative side. So let's make that negative pi divided by 3. Now, it's also going to move down 1. So let's put negative 1 right here. And I know that's going to be the center of my tangent graph. Okay? Now, to find the amplitudes, to find the asymptotes, I need to go half a period to the left and a half a period to the right. That's how a tangent always works. So we said half a period is pi divided by 4. So I start at negative pi over 3, and I add pi over 4. Okay? Again, fraction work here. I need common denominators of 12. So this is going to be negative 4 pi over 12 plus 3 pi over 12 gives me negative pi over 12. And that's how far my asymptote is to the right. All right, so let's go right about here. Put my asymptote, and we're going to call this negative pi divided by 12. And then continue my asymptote. Let's redo that. All right. Try to make those asymptotes straight if you can. All right. So negative pi over 12. Now, let's go to the left and find the vertical asymptote to the left. That's negative pi over 3. I don't want to subtract pi over 4. That's half my period. Common denominators again, same ones I had before. Negative 4 pi over 12 minus 3 pi over 12 gives me negative 7 pi over 12. So my next asymptote is going to be out here at negative 7 pi over 12. And I'm going to give that an asymptote. Just try to make it straight up and down as possible. There we go. All right. So there are my two asymptotes. Now, a way you can check this is find the distance between those two asymptotes, right? From 7 pi over 12 to negative pi over 12, that's a distance of 6 pi over 12 units, which reduces to pi over 2, which is your period. So you should feel good about that. I feel good about those being my asymptotes. Okay? Now, not done with the x-axis. You got to find the halfway point here and the halfway point here. So whatever technique you're using, if you want to pause the video here, whether you're going up by 1/4 of the period each time, or whether you're adding fractions, adding the endpoints and multiplying by a half, whichever you're doing, see if you can't find these last two key x values. All right, I'm going to do this one first. So that's negative pi over 3, and then add it to negative pi over 12. If I add those up, I need to make this negative 4 pi over 12 minus pi over 12. That's negative 5 pi over 12. And then I have to multiply that by a half. So that's negative 5 pi over 24. Again, sometimes these get ugly. Not much you can do about it. So let's do, just trying to see here. Okay. So let's go and put the negative 5 pi over 24. Let's try to figure out a good spot for it. Let's just put it up top. Negative 5 pi over 24. I might have to move that, but okay. Last key x value. I want to start at negative pi over 3. I want to add negative 7 pi over 12. And then we'll add these up find the midpoint. So again, same common denominator. This is going to be negative 4 pi over 12. So this is going to be negative 11 pi over 12 times a half. This is negative 11 pi over 24. which is this value here. Negative 11 pi over 24. Okay, so again, sometimes the hardest thing in finding these x values, if you want to double check it, 1/4 of my period, so if I take that times the fourth, is pi over 8, and that's what I should be going up by each time. So a quick way to check it is take negative 7 pi over 12 and add pi over 8, right? And I should get negative 11 pi over 24. So if I did common denominators, negative 14 pi over 24 plus 3 pi over 24, that's negative 11 pi over 24, which makes me feel good about that value right there, okay? If I add pi over 8 to that, I'll get negative pi over 3, and et cetera, et cetera. Okay. So there are my key x values. Now, to finish the graph, again, amplitudes don't exist with tangent graphs, but the amplitude tells us how high we're going to go to get to this point here and this point here. So one point goes up, one point goes down. So I'm going to go 3/4, not up to the x-axis, but 3/4 units up to get there. Here's negative 2, maybe down there. I'm going to go 3/4 units down. So negative 11 pi over 24 and there, right? Not fully all the way, not down to negative 2, 3/4 of the way down to negative 2, not up 1, 3/4 of the way up 1 from the middle. And there's my graph. So let's sketch it in. It's going to curve in, go through all 3 points, and then curve back up. And there is my tangent graph with all the different transformations going on. Moved it left pi over 3, moved it down 1. We shrunk the amplitude, we shrunk the period, and we kind of vertically shrunk it a little bit. Instead of going up and down 1 to get to those other key points, we went up and down just 3/4 units. Okay, so the last worksheet here doesn't have as many graphs. It has 3 graphs and then a few working backwards. It's 34.5 homework part 2. So go ahead and do the same procedure. Check the graphs with my answer key on Schoology and submit it when you're done. As always, if you have any questions, stop by my office hour and ask